Pythagorean theorem today, and the Pythagorean theorem, first of all, only works for right triangles, okay? So a triangle that has a right angle in it. And it works for the sides of a right triangle. So this is interesting because I think every time we do this, people are like, Mrs. Clark, I thought you said that they add up to 180 degrees. What did I say added up to 180 degrees?
The inside.
The inside, the angles. You're absolutely right. So what are we talking about today? We're talking about the sides, okay? On every right triangle, there is a hypotenuse. Does anybody know what the hypotenuse is?
I know that word, but yeah, same. I only know it.
It's the longest side. The hypotenuse is the longest side. And it's always opposite from the biggest angle. And guess what the biggest angle is in a right triangle? The 90-degree angle. So if I go across from the 90-degree angle there, I have my side that's called the hypotenuse. Now the hypotenuse is always the side across from the 90-degree angle. The other two sides are called A and B. The A side is normally across from the angle A. B side is across from the side B. But really, I'm going to tell you, it doesn't matter too much about A and B as long as you know which one has to be C. And which one has to be C? The hypotenuse. Always the hypotenuse is C. Can you guys get that in your brain? Okay. So we have this rule that says if I want to know the hypotenuse, I can go A squared plus B squared and it equals C squared. This is kind of written backwards than the way I normally write it. I like to write it in this order. But is this the same as that formula right there? It is the same, right? So I'm going to take one side of my triangle and square it. Take the second side of my triangle and square it. And it will be equal to the hypotenuse squared. So I'm going to use this formula today to find the third side of a triangle. Sometimes we'll be looking for the hypotenuse. Sometimes we'll be looking for one of the sides. Either way, we can use the same formula. It will just solve a little bit different. So let's look at this triangle right here. First of all, let's decide that I don't know the hypotenuse, right? I know I'm looking for the hypotenuse. I can tell it's the hypotenuse because it's opposite of the right angle. So my hypotenuse I'm looking for. Does it matter if I call this side A or this side B? It doesn't matter, okay? Because guess what? The formula said A squared plus B squared equals C squared. Now I say this to you guys all the time, but I'm going to say it again. If I have 2 plus 7, is it the same as 7 plus 2?
Yes.
Yes. Addition can be done in any order. So it doesn't matter if you put the first number here or the first number here because it can be done in any order. Okay? So it doesn't matter which side you pick as A and which side you pick as B. It will work out no matter what. So I kind of just like to pick one and get started. So I'm going to say 4 squared plus 6 squared, and I don't know what my C squared is, so I'm going to say equals C squared. Are you following me on how I plugged that in? Okay, now we're going to just do the arithmetic. What's 4 squared? 4 times 4 is?
Oh, wait. 16?
Yep, 16. And then 6 squared would be 6 times 6, which is 36. Add those together for me, please. 52. Now, I know that 52 is C squared, but I don't want C squared. I want C. So how do I get the squared off of the C?
Divide.
Ooh, that's a good guess.
Multiply.
What's the opposite of squaring something?
Cube.
Ooh, that's close too.
Square root.
Square root it. I'm going to square root it. You guys just go ahead and do that on your calculator. We're going to change to decimal point numbers today. Sometimes we'll leave them as radicals.
So it's 2, 13.
2 square roots of 13. So sometimes today on your worksheet it asks you to keep it in radical form. If it says keep it in radical form, this would be your answer. If it asks you to make it in a decimal form, you're going to hit those arrows on your calculator and change it to a decimal point number. And what do you get when you do it on as a decimal point number? Round it, say, to 2 places for me. 7.21.
How do you get the decimal?
Those 2 little arrows at the bottom of your calculator right above the enter sign. If you get the 2 square, it's a 13 on your calculator.
Oh, 7.2.
And you hit these arrows right here, then it will give you the 7.21.
I was trying to do that yesterday, but I couldn't remember which arrows it was.
Yeah, those arrows right above the enter sign will go from exact measure to decimal approximation. Okay, so what we're saying here is this side measures 7.21. Now I'm going to just check to make sure that makes sense in my head. We said that the hypotenuse had to be the longest side. Did my hypotenuse end up to be the longest side?
Yes.
Yeah, so I'm probably correct. So are you seeing how you can kind of just look to say, oh, that makes sense? Okay. All right, here's another example. This one clearly is the right angle. So this has to be my C value. You're right, the hypotenuse. So does it matter which one I put in for A or which one I put in for B? It doesn't matter. Okay, so I'm going to go x squared plus 15 squared equals 21 squared. So do you see this time how I have the C value? So I'm going to put it in where it belongs. If I have C, it goes in on the other side. Now this is still just arithmetic where I'm going to solve this equation. So find what 15 squared is for me.
225.
Perfect. And what's 21 squared?
441.
441? Okay, my goal is to get the x by itself. So what do I have to get rid of? Yep, do it. Minus 225.
216.
216?
Yep.
Thank you. Now, how do I get rid of the squared? You square root it. So square root 216 for me.
6.
So if it asks for it in radical form, this is my answer. If it asks for me in decimal point form, round it to 2 places for me. Well, in that case, it's going to round to 1 place, right? Because of the way it's going to round. What do you get?
14.6.
Yeah, I'm going to go to 7 because of that 9 behind it. Okay, 14.7. Questions on how I use that formula? We doing all right still? It's not too bad, right? Okay, one more time. I know my C value is missing, right? This is my hypotenuse. So I'm going to plug in an A and a B. It doesn't matter which one's A. It doesn't matter which one's B. So just grab them and plug them in. So 16 squared plus 12 squared equals C squared. And then we're just going to do the arithmetic to solve this. 16 squared is 256. 12 squared, 144. Add those together for me. Even. Then what am I doing? Exactly, I'm square rooting it. And I get C equals
12. Wait a minute, hold on.
I'm like, that's not right.
20.
20.
I did 144.
Yeah. So C equals 20. So the length of my hypotenuse has to be 20. Again, you're like, oh yeah, that makes sense. 20 is bigger than both 12 and 16. So it could be the right answer there. And it is because of our work. Okay. One last question. It says determine if the triangle is right. Well, if it's right, guess what happens? This side of my equation, the a squared plus b squared, would have to be equal to the c squared. So I'm just going to plug in all 3 of my numbers and see if it works. So 10 squared plus 12 squared. I want to know if that equals 15 squared. I'm going to put a question mark there because I don't know if it does. 10 squared is 100. 12 squared is 144. 15 squared is 225. Whoa. Do these add together to be this? No.
469.
This is 244, right? And does 244 equal 225?
No.
No, they're not equal. So when they're not equal like this, it is not a right triangle. Okay, if they would have equaled each other, then we would have known that it was a right triangle. Okay, so let me give you an example that works just to show you real fast. Okay, I know that if A is 3, 4, and 5, and I would do 3 squared plus 4 squared equals 5 squared, and I'd want to see if that works. So 9 plus 16. How much is 9 plus 16?
29.
And how much is 5 squared?
25.
Do you see how that would make it right? 25 equals 25. So this makes it so you know that it is a right triangle. Okay? That's the Pythagorean Theorem today, you guys. It works only for right triangles. And the most important side to know is that side C, to make sure that it gets on the opposite side of the equal sign.